Hello friends, welcome back. This is the fourth episode on motion in a plane. We have done enough vector algebra to understand. We have understood that how the vectors are resolved, whether 2 dimension or 3 dimension in given directions. We have understood the whole geometry of it. We have last episode we were able to see the motion of a particle through its position vectors. We were able to derive its velocity, and we could find that the instantaneous velocity or the velocity of the object or the particle, moving particle, is along the tangent of the path. So far we had done. Now let us see what happens to the acceleration. This is very important. This is very important, my dear friends. In a case, remember, in a case of a motion in a straight line, the velocity is always in the direction of motion. Velocity is always in the direction of motion. You know it. Acceleration is also along the direction of motion, maybe in the same direction or maybe in the opposite direction, depending on acceleration or deceleration, whether the body is increasing its speed or decreasing its speed. Means in the straight line case, in the motion in the straight line case, the velocity and the accelerations both were in the same, both were along the direction of motion. Recall it is okay. Now let us see what happens in this case. In the case of a plane, in the case of a plane, what happens? Let us see. It is very interesting, my dear friends. It is very interesting. We will do it graphically. So obviously, we know that by definition we know that acceleration is rate of change of velocity, means vector A is equal to change in velocity in change in delta t. Remember, we will be considering the cases throughout this textbook that acceleration is uniform, constant acceleration. It means that the dA by dt is always 0, means the acceleration is uniform. Some books say it constant, some books say uniform, both are the same thing. Okay. So, dA by, so the uniform acceleration or constant acceleration. I also use sometime constant, sometime uniform, but means the same thing. D by delta v by delta t is equal to v v x I. Now, I have been able to resolve it v. Now, this is the vector quantity, v x and v y are just the numbers, v x I, v y j, these I and j are the vector quantities. So, I can rewrite it delta v x delta t like this, or this I can write a x, the acceleration in along x axis and acceleration along y axis. So, the acceleration vector can be rewritten as again as the resolved vector and one along x and y directions respectively. Had the case been in space or 3 dimension, then third component a z k would have also appeared here nevertheless. Now, again the same thing, if we see it, if delta t decreases 0, it means when then these quantities are becoming the differential quantities, we can write the differential calculus dx by dt. So, a x is nothing but dx by dt, d by dt of velocity, and velocity can be rewritten as dx by dt. So, this is a second order differential equation, second order differential d 2 x by dt square. Similarly, a y can be written as d dot 2 y by dt square. This in the last chapter you have done this much calculus, you must have done in last chapter in chapter 3. So, this much calculus is required to study. Friends, this it is a little ironical that the differential calculus, though it appears to be a part of mathematics, but always physics teachers are compelled to do it before it is being dealt by the mathematics teachers. It's very interesting that Newton, who is considered to be the father of calculus, he had to discover calculus to express the motion equations in 3 dimensional space, etc., in motions, to express motion effectively, efficiently. So, it came from the demand, as if the demand in the description of motion, but later it became a part of mathematics, but the physics people have to do it much before it is really dealt by the mathematicians. But yes, of course, Newton was a great physicist and is considered to be a great mathematician as well. He had to discover calculus beforehand. Now, let us see the instantaneous accelerations, instantaneous things. So, the a is nothing, the acceleration is nothing, but limit delta t tends to 0 delta v by delta t. I think there is no need to further explain this we have explained several times. Now, since delta v can be written like this, we have a, if you write all these things, we can write this we have already got. So, in the forms of limit we have got this, and a x and a y are this. Now, if we see it graphically, friends, you will find it interesting. It is really very interesting. It is a beauty of science, beauty of graphs. See, let me say a point P here along the path of the particle or the object, which is shown by blue line here at time t is equal to is, let us say it is at point P. So, the tangent gives you the velocity vector at this point. So, this is the velocity. Now, if it continues moving along the right direction and after some time it reaches to point P 1. Now, the tangent at P 1 will give its velocity at that particular point. So, this is the tangent V dash, right. Now, look at this diagram. If I happen to do the mathematics of it, then at some time the velocity will be like this. The velocity, two vectors, the change in velocity will be given by this. See, we are doing subtraction. So, this is triangular law. So, this is triangular law of vector addition, a minus b. So, you will find this value. So, delta v comes out to be in this direction. Delta v comes out to be in this direction, friends. Look at the direction. Delta v is not in the direction of v at any instant. Delta v is in different direction. Now, so the acceleration will also be in a different direction, right. Is that clear? Acceleration would be in different direction. Look at this diagram. Now, look at this point P 2 at this point. Now, what will happen? So, the direction, if we do this, the direction of acceleration is this, direction of acceleration is this. Now, again if we, now what we are doing, that we are reducing the positions P 2 P 3, larger distance, shorter distance, even shorter distance, and now delta t is 0, is tending towards 0. Now, delta t is tending towards 0. So, the difference between P and P dash is becoming absolutely, is coming very close to 0. So, let us say it to be a point P. Now, if you will find that you can understand with these diagrams very easily that, now you can see it with the understanding of these diagrams, that at this point P the acceleration is perpendicular direction. The acceleration is perpendicular direction to it. So, towards the normal, not towards the tangent, towards the normal. Now, you are seeing the velocity is along the tangent, acceleration is along the normal of its. This is the beautiful thing in motion in a plane. Tangent, and this gives us the understanding of whole understanding of circular motion and projectile motion, etc. This has led to tremendous kind of applications and motion, understanding motions of all the things, motion of the birds, flying of the birds, etc. That acceleration, earlier in the case of the straight line, we were compelled to understand that the velocity as well as acceleration and the displacement all were in the same direction, but now you have seen that these are different. Velocity is along the tangent, but acceleration is along the normal. Okay. Understand it very clearly, my dear friends. This is very important points. Now, along the curved paths, it means along the curved paths at a particular point, the velocity is along the tangent and the acceleration is along the perpendicular to it, right. Yes. Motion in a plane with constant acceleration. The acceleration a is constant, okay, which I have been taking right from the beginning, right in the beginning, that uniform acceleration means constant acceleration. Now, at t is equal to 0, the velocity is v naught, the position vector is r naught, and at time t is equal to t, some other time t, the velocity becomes v and the position vector becomes r. Then by definition a is equal to v minus v naught by t. These are vector quantities, my dear friends. T minus 0 is equal to v minus v 0 by t. So, this gives you an equation, v is equal to v 0 plus a t, the equation of motion in 3 dimension, equation of motion in a plane. Equation, the similar equation of motion which you got in the case of a motion in a straight line, the similar equation. Now, in terms of its components, you can rewrite it like this, and similarly you can express s, the displacement r minus r naught. So, this gives you the expression something like this. So, this will again lead to the similar kind of equation which you get, the equation of motion which you get in the case of single dimension, in the case of a straight line. So, the average velocity v naught plus v by 2, the displacement is r minus r naught. Right. So, by simple doing the calculations, you can get r minus r naught is equal to v 0 t plus half a t square. Remember, this is a vector quantity, this is a vector quantity. So, this whole is a vector quantity. So, since this is a vector quantity, this is the position vector at time t is equal to 0, this is the position vector at time t is equal to t, or we can write r is equal to r naught plus v naught t plus half a t square. Now, if the particle is starting from origin, that is r 0 is equal to 0, that if that is particle is starting from origin, that is r 0 is equal to 0. So, my r will become v 0 t plus half a t square. Do not you find this equation very familiar to you? Yes, it is. This is the same x s is equal to u t plus half a t square. This is the same equation. So, same equation along x axis, same equation along y axis. Friends, this mathematics is very important for us, because this gives us the beautiful reductionism, that if we are seeing a motion of a particle in a plane, we can do it, reduce it to a problem of motion of particles in two mutually perpendicular directions x and y. Similarly, if we are seeing a motion of a particle in a space 3 dimension, we can reduce it as the motion of the particle in 3 mutually perpendicular axes called x, y, z along I, j and k unit vectors. Now, yes, let us come to the relative velocity in 2 dimensions. A lot of it you have already done in last chapter. I have just to revise it, just and then to add something. Let us say there are 2 objects A and B, which are moving along x axis, having their initial positions at x a and x b, moving with velocities v a naught and v b naught. So, at time t, at a later time t, this is the position at time t is equal to 0. This argument 0 tells you that as if it is at time t is equal to 0. Now, at argument time t is equal to t some later time. So, using the simple equations, we can rewrite x a t is equal to x a 0 plus v a t. Okay, and this is a simple algebra, initial position plus the distance it has moved along x axis with the velocity v a in time t, simple. Similarly, in b, similarly along b axis, and now the displacement from the object a to b, displacement from as seen by object to b, the relative positions we are seeing, friends. This can be given by x b a t, this is nothing but x b t minus x a t is equal to this minus this. Now, you see with this explanation of coordinates, you can find the relative velocity of b with respect to a is equal to v b minus v a. I am talking about magnitudes here, and obviously, this will be go I and j as the case is there. So, similarly, I can rewrite the velocity of a with respect to b, that is v a b, and if you do this, you will find the vector v b a is nothing but the negative of minus v a b, and their magnitudes are same. So, this is all about the relative velocity in this case. Now, let us do some example. This is the example which I did last time, similar time of example while we are adding the 2 vectors. Now, the case is different. In the earlier case, you recall the child was standing at the bus stop and the rain was falling downwards and the wind was blowing from east to west. Now, the case is of a woman who is bicycling. Now, I have kept the same numbers just for the case of understanding it better. You can do it with the different numbers. So, this is the problem here. Rain is falling vertically with a speed of 35 meter per second, as it was happening in the boy case who was standing in the bus stop in the earlier case, and if there is a woman who is riding a bicycle with a speed of 12 meter per second in east to west, right. Now, in which direction should the woman hold the umbrella? In earlier case, my dear friends, what was happening? The wind was blowing. Now, the wind is not blowing, the woman is bicycling. Now, what should happen? Now, what will happen? Now, let us see the case. So, the v b, this is the bicycle speed vector and this is the rain vector, right. Now, we have to subtract it, rain minus this vector which is bicycle vector, this is it now. So, this is V r minus V b is this V r b. So, this now rest of the calculation you can do, this is very simple. So, that you can get the theta angle is equal to 19 degree. Now, unlike have you understood it properly? I believe, I am sure that you must have understood that the lady should hold the umbrella like this, I mean angle 19° from her back. Now, if we do it, fortunately, now look at the, compare it with the earlier question where the boy was standing in the direction in the at the bus stop. Now, what he has to do? Now, he had to keep the umbrella like this. So, in this case the two vectors were added, and in the case of the woman where the woman is bicycling, the umbrella has to be kept behind, and these are very particular. This you might have experienced in your daily life. If you are moving, then you have to keep the umbrella back, and if you are standing, then you have to keep the umbrella in front. This all you have done. How you do it? Now you are understanding the mathematics of it, friends. Now let us do a practical example of it, that is projectile motion. What is a projectile? A object which changes its position in a plane and which is thrown at a direction making some angle with the two axes is called a projectile, which remains in the air. Okay? Whether you fire a bullet, you throw a ball, or whatsoever you do, all those are the example of projectile motion. Let us try to do this example beforehand. So, now yet again you will see that this is a motion of two motions. This can be decomposed in two motions along x axis and y axis, which Galileo proposed in 1632 book. Now, here if you are throwing a particle, an object here, suppose a book or something like that, making an angle theta 0 with the horizontal. Now, you can understand its components v 0 cos theta 0 and v 0 sin theta 0 at this point. Now, it is changing. Now, look at this point. See this object which we have thrown with an angle theta 0 has two motions along y axis and along x axis. In this case, we have only one motion along y axis, free fall. Now, in this case, we have the two. So, motion along the y axis is governed by law of gravity. So, here you have an first it is going up, acceleration is just acceleration due to gravity minus g. Remember, the force is downwards. Okay? So, it is going up. So, g t. Now, similarly, but there is no acceleration along x direction. So, along x direction this is uniform motion, along uniform motion. So, the two components of the velocity. So, along x direction it will keep on moving with velocity v 0 cos theta 0 like this, and along y axis it will keep on moving like this. So, if you combine the two, you will find a motion like this. You will find, let me repeat it graphically. Along y axis you will see the motion like this, free fall. Along x axis where the velocity is v 0 sin theta 0, it will keep on moving like this. So, if you combine the two motions, if you combine the two motions, the object will moving like this. So, this is the projectile motion. Is that clear? Now, so this is what is being shown here in this graph. So, this is acceleration vector, and along x axis there is no acceleration. Now, with this geometry, if you see, now let us try to convert this geometry into algebra. So, at time x 0 the position was 0, y 0 was 0, this is clear, this point. Now, acceleration is only in y direction with a numerical value minus g, a x is 0. So, therefore, a y is equal to minus g. Similarly, v 0 x, the velocity along x direction is v 0 cos theta 0 and v 0 y is v 0 sin theta 0. This you can see very analytically, we have discussed a lot. Now, after time t, what is the position? Along x axis there is no acceleration. So, the equation of motion is v 0 x t. So, this equation will give you the uniform speed, uniform motion. Now, similarly, y, where you have an acceleration towards minus y axis, So, equation of motion is this, and this will give you these answers. Now, the angle you can very well define it by v y by v x at any point of time, where v y and v x are given by these two equations. So, now during the whole path of its journey, the velocity will keep on changing through these equations, and the angle with horizontal will keep on changing through this equation. So, the equation of motion, if you see x and y, these two equations. If you see ponder upon these two equations, you will study in mathematics a lot about it. This equation will come out to be. So, if you try to write y in terms of x, you will find this equation. I am not doing the whole algebra of it, you can do it, this is not difficult, this is very easy, you can do it, and you eliminate t from these two equations. You eliminate t from these equations, and t is equal to x by v 0 cos theta 0 divided by x divided by v 0 cos theta 0, and you put in this equation, you will get this equation, and this equation is a parabola equation. So, this is why this goes like this, the parabola. This goes like this parabola. Next slide will show you the whole catenary. This is a parabola. So, here it comes. So, at the point of maximum height, this is the point of maximum height, friends. Your height at highest point will become 0. How it goes? A free fall. Understand free fall, compare it with the free fall. At the height maximum point, its velocity becomes 0. So, this is the point, v y is equal to 0, and this is the if you say that t is the total time of flight from here to here, then here to here, then half of the time will it take to go to the maximum point, and then the remaining half of the time it will go to the again to the ground. So, at t is equal to capital T by 2, what is capital T? Yet again the total flight time. So, v y is equal to 0. So, at the highest point, this point where velocity in y direction is 0, and however, the velocity in x direction is again the same, v 0 x I. I am considering no air here. In this case, the air resistance is 0. There is no air resistance, my dear friends. So, the angle at this point I can find out from this equation, v y is equal to 0. So, tan inverse 0 is equal to 0. So, theta is equal to 0. Clear? So, similarly, I can write v y t is equal to this equation, and I can find out the time of flight from this equation is t is equal to 2 v naught sin theta naught by g. This t will give you the time of half flight, and multiply it, you will get the total time of flight by this equation. This is very important equation. Next. Now, time of flight is this. So, maximum height attained in this case y is equal to h m at t is equal to t by 2. You can find out what is the displacement in y direction. You remember this equation, parabola equation, right. Now, this equation again, if you put all these values, you will get this answer. You will get. Now, if theta 0 is equal to 90 degrees, say vertical, motion is vertical. Now, motion is vertical, theta 0 is equal to 90 degrees. So, sin theta 0 is equal to 1. So, it will become v 0 square by 2 g. This is the usual answer which you get in the simple mechanics. H is equal to the horizontal. What is the how much distance it has moved? You might have seen that it is being advised that in the game of cricket or in the game of football, that if you want the ball should go at the highest distance, the largest distance, you are advised to kick it at an angle of 45 degrees. Similarly, in the case of football or similarly in the case of cricket. How so? Let us see. This is what is happening. Horizontal range is nothing but r is equal to v 0 square sin 2 theta 0. Sin 2 theta 0 is coming because here I am using 2 sin theta cos theta is nothing but sin 2 theta. This is the trigonometric identity which I have used here. Now, if you put theta 0, this is sin 2 theta. Sin 2 theta will have maximum value 1, it can have maximum. For r being maximum, sin 2 theta has to be maximum. Sin 2 theta will be maximum only and only when this theta 0 is equal to 45 degree. So, that this will become sin 90, sin 90 is 1. So, at 45 degrees r is maximum, which is nothing but v square by g. So, now you can see that why it is being advised to kick the ball or hit the ball in the game of the cricket at an angle of 45 degrees. Clear? Now, let us take another example of uniform circular motion. Uniform, it is also an interesting example of the same thing of circular motion, where you will see the centripetal acceleration. Centripetal acceleration you will see. Now, let us say that a particle is moving like this on a circular path, right, with a velocity v. So, at every point the velocity vector is towards the tangent of it. So, if at this point this is this and this delta theta. Now, if you find this, if you see the delta v vectors and v dash vectors, and if you find the change in velocity delta v, this will be along this. You are doing v minus v, we have done it before. So, So, delta v by delta t is acceleration. So, acceleration will also be towards this direction. Similarly, at all other points. Now, if this delta t becomes 0, delta t becomes 0 very close by. So, you will find acceleration is towards the center of this path, that is, and then it is called centripetal for acceleration, and the force associated with it is called as centripetal acceleration. So, in terms of the rotational dynamics or rotational mechanics, you can say the centripetal force, which is nothing but v square by r, which you will find out to be, in terms of the frequency, AC is equal to 4 pi square nu square r, and this is all in this chapter. I hope you might have relished it. Thank you very much. Goodbye.